Hello, everyone. I'm Anna Ogorzałek. I'm a postdoc at NASA Goddard and University of Maryland College Park. Thank you for staying for one of the last poster talks today. I'll use my 5 minutes as a teaser for our upcoming paper on NGC 4051, and maybe to start some conversation about some more technical topics that I'm interested in. Next slide, please. In short, we study absorption features in the X-ray band imprinted by accretion-driven winds in AGN. So we're looking at two very long Chandra HETG observations of NGC 4051, which is a local Seyfert galaxy with a low black hole mass that is known for abundant absorption. The two epochs that are studied are an observation from 2008 and one from 2016, so they're spaced almost a decade apart. Next slide, please. We've utilized a Bayesian approach, which has two main advantages. Firstly, because we use Monte Carlo Markov chain process and calculate our models self-consistently on the fly, we keep the parameter space fully open, not restricting any of the key parameters such as line width or density, like for instance, many of the grid modeling do. Secondly, using a Bayesian framework gives us a straightforward tool for model comparison, also when it comes to comparing different non-nested models, which a typical frequency C-stat approach does not really allow us to do. Next slide, please. So we detect 6 absorbers, and remarkably, they show independently in both datasets. Here I show their column density and velocity. We have 3 distinct groups of absorbers: slow absorbers that are moving at a few hundred kilometers per second, fast ones moving at few thousand kilometers per second, and ultra fast ones moving at tens of thousands up to 10% of the speed of light. So these components, for example, span line widths from 200 to few thousands kilometers per second. So keeping that parameter space open was crucial for getting the full picture of the outflow here. Some variability is clear, especially in the fast wind components. And most components are photoionized, and we have obtained good ionization and also density constraints for those interested in density, which you will find in the paper. But one of the biggest results of this work, and here, next slide, please, is that one of the slow absorbers is actually in collisional rather than photoionized equilibrium. So here I want to emphasize the advantage of the Bayesian approach, because it allows us to make statements about which ionization model describes the data best, even though these are not nested. The collisionally ionized absorber here is remarkably constant in between the 2 epochs, as you can see by the parameters shown here, at high column density and high temperature. And I will note here that previous work by Andrew King and Ken Pounds have proposed a collisionally ionized shocked wind in this object by looking at emission lines with RGS. But now this is the first time that we see something like that in absorption. Next slide, please. So clearly, this teaches us something about the physics of the accretion winds, and we learn more about it from all of the wind components here in NGC 4051, some of which we find as close as few hundreds of gravitational radii away from the black hole, thanks to our precise density constraints. And in total, the wind is as powerful as 10% of the AGN bolometric luminosity, which is important in the context of AGN feedback. So to learn more, please keep an eye out on the paper within the next few months. Next slide, please. But as for the technical aspect of this work, I would be really keen to chat with people at this particular workshop about ideas for speeding up for the photoionized model calculations, since currently it's either restricting ourselves to grids and not really exploring the parameter space, or paying large computational costs. So if there was something better, that'd be really cool to know. And secondly, I'd like to know something that I already see people discussing at length on Slack, how to best assess systematic uncertainty from atomic data on the models that we use, both for collisional equilibrium and photoionized equilibrium. So thank you, and please drop me a line if you want to chat.